Okay, so we're going to go ahead and fill out this form, and you can follow along and do it as I do it. So we're going to pick a number between 1 and 25, and I'm not that creative, so I'm just going to roll a die. Okay, so 8 is going to be my test number. Now I'm going to write an equation here. This is actually like an equal sign between these two. And this number that I pick is just any random number, and just as a placeholder, I could put a variable in there. So for example, x. So now I'm going to take my number and I'm going to add 9 to it. So if I just ignore the equation for a second, if I add 9 to 8, I would get 17. And then the way the expression gets built is I would add 9 to x. So x plus 9 would be the expression for any general equation. Okay, so now the next step, we didn't write it down. I just wanted you to pay attention, so not work ahead of me. So that's going to multiply by 3. So I take 17 and multiply by 3, and that's 21, 3, 4, 5, 51. Okay, so my new number is 51. And now what I do is I want to multiply whatever this number is, right, this unknown, times 3. So the way I would write that expression, and I couldn't just write 3x plus 9, 3 times x plus 9, because really I want to multiply 3 times that whole thing, x plus 9. So that's where parentheses come in. And we want to make sure that we're adding 9 to it first before we're multiplying it by 3. Okay? So the next step, we subtract 6. So take away 6 from 51, and we get 45. Okay, so that's equal to 3. Now this whole thing gets repeated. So this is that number, and I'm going to take away 6 from it. So I could put brackets around it and say take away 6, but that's the same, right? This the order of operations doesn't really need these parentheses because we would already do the multiplication before we do the subtraction. So I'm just going to leave those off and just write it like that. Okay, now we're going to divide that thing by 3. So 45 divided by 3 would be 15. And then, well, some people don't believe me sometimes, so I'm going to divide 3 goes into 4 one time, and 3 goes into 15 5 times evenly. So there we go, just to prove it to you. Some people forget how to divide, so I just wanted to remind you of that. So now we take this whole thing, and we're going to divide it by 3. Right? I could put it in parentheses, but actually, division bar represents a group too. So there's parentheses represent groups, brackets represent groups, and also division bars represent groups. If something's on top of division bar or the below the division bar, you have to do everything there before you do the division. Okay, so subtract your original number. So my original number was 8, so I subtract 8 from 15 and I get 7. And the way that expression looks over here would be this whole thing, and I'm subtracting my original number, which was, and instead of writing 8, I'm going to write my original number was x. Okay. So that's how you build these expressions, and you can show actually that this whole thing is actually equivalent to just x, I believe. Or no, it's always equal to 7. That's what it is. So no matter what number you put in here, you always get 7. So when you did it, you probably got 7, and any number that you put in there, you'll always get 7. And it's probably because these x's would cancel out when you simplify this expression. All right, let's do a couple more and see where we go with it. Okay, so pick another number between 1 and 25. I'm going to take a little bit smaller number, so I'm going to roll a 12-sided dice. Okay, 6. So my test number is 6, and my unknown, right, is x. So x is equal to 6, I'm going to say. I'm going to add 7 to it, so that's 13. And that would look like x plus 7, right? Now the next thing I'm going to multiply by 4. So 13 times 4, I believe, is 42, but I'll just prove it to myself. 3 times 4 is 12. Carry the 1. 4 times 1. No, it's not. It's actually 52, right? And up next, so I say, let's see, 4 times that whole number, right? So I need to put this in parentheses because I add 7 first, and then I multiply by 4. Now I'm going to subtract 16, so 52 minus 16 is, borrow a 10, and that's 12 minus 6 is 6, and 4 minus 1 is 3. So I get 36. And I'm taking this whole expression and I'm taking away 16. Alright, now I divide by 4, so 36 divided by 4 would be 9. And I divide this whole thing by 4. And I could use the division bar because the division bar is a group. Okay, and then the last thing is to subtract 3, which I would get 6, and all that, minus 3. And this one, I believe no matter what number you pick, you will always get your original number back. And you could probably simplify this expression so that you show that it's always equal to x. Okay. Up next, we'll just do one more. You can put any old title you want for this. Maybe after we find the answer, then we'll think of a creative name for it. Okay, so pick a number between 1 and 25. Let's go even smaller this time. Let's try. So this when you read the number on the bottom, this is a 1. So I'm going to use 1. Okay, so these are blank, right? So I have to figure out what's happening here. So first, I multiply by 9. Oh, that makes sense, right? 9 times x. So 1 times 9 is 9. Now, what do I do here? It looks like in the equation, we subtract 18, right? So this is subtract 18. So 9 minus 18, I actually get a negative number, right? So that'll be negative 9. Then what do I do here? It looks like I divide by 9. So negative 9 divided by 9 would be negative 1. And then it looks like I subtract my original number, right? Subtract original number. So negative 1 taking away a 1 would be a negative 2. And the final thing, it looks like add 2. So negative 2 plus 2 will be 0. So I think this one always ends up being 0, and you can maybe rearrange this equation to show that it's always equal to 0, right? Maybe what's a good name for that? So it's always going to 0. We'll call it how about the annihilator? Annihilator. I don't know if that's even spelled correctly, but it sounds funny. So think about that. As you're building an expression, this looks like a pretty complicated expression right here, but all it is it's just doing one operation after the other, right? So think about that. When you look at an expression, what's actually happening in here? If I just saw that, how would I get back to that, right? So you might think about, what was the last thing that we did to this? We added 2, right? Before that, we took away x. Before that, it looks like just to unwrap to get back to that x by itself, what do we do? So we're going to do that in the next video, and we're going to try to undo the process, start with something like this, and go to backtrack all the way to x. So think about that up for the next video.